In this tutorial, we are going to have a look at a special workflow that combines color mapping and inspection tool with the newest depth grid function. The goal is to get the highest and the lowest value on the surface represented qualitatively by a color mapping and quantitatively by a depth grid. To run the inspection, you need a mesh model, that is the reference model, and a point cloud, that is the inspected one. Never mind if you would have to inspect 2 point clouds or 2 meshes. Reconstructor offers all the complete tools to convert one point cloud into a mesh and vice versa. The inspection allows to calculate the distance from points to the mesh surface and then display results in color mapping. The mesh model can be a Reconstructor mesh or any kind of CAD model. IFC is as well supported. In this example, we will use a mesh created in Reconstructor, starting by a reference horizontal plane to check the floor planarity. To create the plane, go to Mesh Toolbox, then Basic Shape and create Edit Plane. Click now on Create New and name your plane. In the fitting menu, there are different options to create the plane. You can edit the plane's dimension according to the floor. The plane just created appears in the project window. Select it, then right mouse click, Meshing, and create mesh from plane. A mesh from the plane is now generated. To better visualize the point cloud and the plane's mesh, go to the main toolbar, select Screen Setting, then Color by ID. In the property browser of each object, you can change the color ID of the mesh and the point cloud. Now, let's select in the project window the mesh and the point cloud that you want to inspect. Go to Measure Toolbox and select Inspection Tool. The point cloud and the mesh will be automatically uploaded in the dedicated recipe window. In Parameters option, set the value of maximum search distance and name the inspection that will be the new color layer added to the investigated point cloud. Here, we are going to call it Inspection Floor Planarity Map. There are different inspection types. Clicking on Change button, you can select the one that mostly fit to the surveyor's requirements. To start computing, click on Plane button. Once it's done, a new color layer will be automatically displayed in the 3D view. And the color histogram is shown in the inspection histogram. At the bottom of the inspection window, click on Color Mapping button. The dedicated Colors Mapping window appears. Here you can change, select and edit any presets or parameters of the color mapping to better visualize the result. Click on Preview to visualize your selected map color in 3D view. In the histogram column, on the right, you can manually edit and change the intervals of distance and colors. In the Inspections recipe window, at the bottom, select Save Report to automatically generate your inspection report in PDF format. Let's explain a bit more about the Colors Mapping window. You can access at this in different ways. In the property browser, selecting the dedicated button, in the Color toolbox, selecting Cloud Coloring. Your customized colors mapping can be exported and re-imported to be used for the next time in the same project. Reconstructor also allows you to add and remove a color layer, as well as merge and split layers to your point cloud. For example, we are now going to add a new color layer with altitude to the Z-axis. All the points of your cloud will be colorized and classified with their altitudes on Z-axis. Respect the current UCS reference system. Now, let's discover how to display the quantitative result of your survey. On the 2D orthophoto, you can add the depth value of each single point or the global grid. To generate the orthophoto, select the CAD Output toolbox, then create X-ray orthophoto. In the recipe window, move on by New and name the orthophoto. You have several ways to create the orthophoto. Using the Quick Selection tool, you can easily select the area on the point cloud to fit the ortho image. As your convenience, you can also use the options by point list, ortho camera and current view. In this example, we are going to use the Quick Selection option. Once the survey area is selected, the software automatically generates a ortho camera in the 3D view. In the option Dimension and Correction, you can edit the dimensions and the position of the ortho camera to better fit to the survey area. Clicking on Preview button, you can check how the survey area fits to the ortho camera. Then click on Snap to generate X-ray orthophoto. Once the process is done, select Open in the viewer to visualize your orthophoto. In this 2D view, using the Depth tool, you can pick and visualize the depth of any single point. Using the Depth Grid tool, you can add a depth grid on your ortho image. After defining the spacing of the grid, here for example we have selected 0.3 meters, you will have points in every 30 centimeters of both horizontal and vertical direction. Now close the viewer and go back to the Reconstructor 3D view. In the project window, select Result, then Orthophotos to display the previous extracted results, single points and depth grid. From the depth grid, you can export all the extracted points into point list or to point cloud, which can be both used to create a model.